Okay, on your paper, I would title this two-way frequency table. I would title this two-way frequency table. Okay, and we made some notice and wonderings on here. So again, we're gonna refocus on the two-way tables. You've seen some of this before. Okay, so on your paper, go ahead and draw this two-way frequency table. Okay, there are two important vocab words that I need you to know. They're joint frequency and marginal frequency. Okay, so you're going to draw this on your paper and then write the words joint frequency and marginal frequency. Take a second, go ahead and write that down. All right, so really quick, joint frequency is any like entry that you have. So it's like a crossover of the categories. So for instance, like this 159 represents 159 seniors that would vote for the masquerade ball. Does that make sense? So it's two categories that meets. Or you could say like one of the entry data points. Okay. All right. Marginal frequency is going to be the totals of each category. Okay. So what I mean by that is all of the juniors, there's 362 juniors, there's 387 seniors. Okay, there's 371 people who voted for the masquerade ball. Okay. Okay, so down here at the bottom, it says on prom night, what is the probability that a student chosen on at random got the theme of his or her choice? Okay, so I need you to think about it. How many people is one person? Oh, okay, cool. Out of how many people in total did we have? Okay, so if we take 749 and we do 1 divided by 749, okay, that would give us 0.001, which if we turn that into a percentage, that would be 0.1%. You remember how like people are like, your vote counts. Your vote is only worth 0.1%.
It still counts.
I mean, it's actually less than that, but because we have more people. But that does not mean don't vote. Does that make sense? Because look at what happens. If you have enough people, guess what? You win the battle. Make sense? Okay. Make sure you remind your parents to vote November 8th. Okay. So number 2, it says, what's the probability that a senior chosen at random got the theme of his or her choice? Okay. So out of all of the seniors, okay, so we got 387, right? Okay. Now, for each one of these, okay, there's a different percentage. So for instance, for casino night, we had 190 out of 387. So what's the likelihood of actually getting casino night? That would be about 49%. Okay. If I was doing the masquerade ball, I would have 159 out of 387, which would be about 41%. And then if you were Arabian Nights, that's probably not going to happen, but 38 out of 387 would be about 9.8% for Arabian Nights, right? Can you figure out what's the probability that a junior chosen at random got a theme of his or her choice? So you're doing the exact same thing I just did for each one of these, but you're only dealing with the juniors now. Okay, can you take a second? Can you try that on your own? Okay, so just kind of checking in with you. We would have had 100 out of 362, which you got what? 28%. Fantastic. And then for this one, we got 212 divided by 362, 59%. Okay. Arabian Nights, 50 out of 362. 14%. Say it again. 14%. Okay, cool. I heard 48. I was like, ha, ha, ha. No. Okay. Questions? Pretty easy, right? Fantastic. This is why we can't have nice things. Way to go, Courtney.
Like, I don't want to look back.
Way to
at
go,
my life
Courtney.
and not have context.
Oh, that's true.
That's
Oh,
why I wanna- No.
Oh.
There's no point. I'm taking notes if I don't.
okay. So go ahead and look at the following frequency table. Notice how there are some empty spots. Go ahead and draw the frequency table, and we're going to try to fill in these little boxes. We're going to talk about it in just a second. Okay, so, okay. If I want to figure out how many people don't have cable TV, but I know that 97 people have cable TV, but I know that there's a total of 111. I can take 111 and subtract 97, and that gives me 14. Oh no, that's okay. Now from here to here, okay, from here to here, I would have 14 plus 17, which will give me quick maths. 166 minus 31 is gonna give me wow. 135 minus 97 is what? Say it again.
38.
Okay. Now if we take 38 and we add 17 to it, and notice how when we add these together, we get this total. We add these together, we get this total. And then the columns all add up. Yeah. Okay, this is what y'all do second semester for geometry. Okay, so what is the probability that a random person selected from this group took a vacation last year? So how many people in total took a vacation? 111. How many people you got in total? 166. So I'm going to divide 111 divided by 166 is 67%. Ta-da! No? Okay, fourth period is more like enthusiastic. Come on, let's go. No.
Yes.
No.
Yeah,
Oh,
like it's never,
that's true.
every Thursday.
Yeah, it's always something. What's the probability that a random person from this group who has cable TV took a vacation? So out of the hey, out of the people who do have cable TV, how many took a vacation? Okay, so we got 97 out of 135, which when we divide it, that's 71.8%. Well, 79. Or you can really say 72. That's okay. Okay. Does anybody not know how to change it from a decimal to a percentage? Just to clarify, if I get 0.719 and I want to change it to a percentage, I would move the decimal places 2 points, and that's going to be 71.9%. Okay. Or you can times it by 100, whatever. That's fine. What?
It's divided.
What's up?
It's divided.
Are you ever? Oh, if you go to a decimal.
I can't hear you. So it just kind of depends on the test. If you want to round up, like if you said 72% on this question, that's fine with me. But like if it's a multiple choice question, it's like 71.9. Yeah, that's the answer. Yeah. What's the probability that someone who does, what's the probability that someone who does not have cable TV, that's just 31, okay, did not go on vacation? 17 out of the 31. So when we divide that, that's going to give us 55%, or you could say 54.8. That's fine. Are there? So apparently there is this new cafeteria rule. Okay. No, it doesn't matter. So okay, so you could put female and male in two different columns. I don't know why that has two L's. Okay. And so then you could put agree or disagree with this new cafeteria rule. I'm not sure what the rule is, but what it says is there's 38 males that agree with the new rule and 70 that do not. It also says that there's 92 females in total. 41 of them agree. Okay, so how do we fill in all these other boxes? Okay, yeah, we're going to subtract or we're going to add certain places. So 92 minus 41 That's gonna give us 51. And then we're gonna take 38 plus 70, and then we'll add going this way. So 41 plus 38 is gonna give us 79. And 51 plus 70 is 121. When we add 79 plus 121, we get, okay, and you should get 200 both ways. If you don't, then you messed up somewhere. Okay, part A, what is the probability that a random student selected agrees with the new cafeteria rules? So how many people in total agreed?
Oh.
Wow, 79. How many there in total? Okay, so we're gonna do 79 divided by 200. No, that should be 39.5%. Okay. What is the probability that a female student did not agree with the cafeteria rules? So out of the females, how many disagreed?
51.
51 out of the 92.
Yeah. Oh.
Okay, so this is basically saying these girls are not happy about whatever this cafeteria rule is. Okay, that's probably what the rule is. Okay. Okay. All right. So Jada apparently runs with her headphones on and off, which psychopath, if not no headphones.
I saw you with your headphones when I walked to that gym. Your purple headphones.
I don't know what you're talking about. So, okay. So Jada ran with her headphones on for 10 times. Okay, that's a really weird. If this thing doesn't stay, no, it's not working. There we go. Okay. So where's that 10 times gonna go? Headphones on 10 times? Okay. 10 of Jada's runs that took 25 minutes or longer were completed without headphones on. So without headphones 10 times. So how many is that going to be in total here? Fantastic. And then it says half of Jada's runs took 25 minutes or more. We already knew that was 14. So that means that this guy is going to be 14, which means that this guy is going to be 18. And then this guy is going to be.
Oh, no, 8.
Oh, okay. Good try. And then right here is going to be. Okay, fantastic. Now, how many of her runs took less than 25 minutes? 14 out of the 28, which is going to be about 50%, because they asked us for the probability. Yeah. Now, among the runs that took under 25 minutes, so out of these runs, what percentage of them were completed without headphones? 8 out of 14, which is going to be, nobody did that math. 21.5%. Thanks, friend. Okay. I don't think that's right. That's 57. It's got to be 57. Macy, way to go. It's going to be 57%. Good try. Good try. So let's go ahead and talk. Okay. So I had 100 students indicate their favorite power was to fly. 49 were female. How many males were there?
51.
Quick math. All right, 131 want the power to freeze. 71 were males. How many females?
60.
Okay. 75 students were invisible, and 48 were female. How many? 77? Sorry. Super strength, there's 26. And 25 are male. Okay. I said this wrong in the last class. Telepathy. There we go. I said telepathy. Wow.
I was saying that.
Whoa. No. Telepathy. That was hard. Reading up people's
That's so
doing.
great. Like, you want to read stuff without.
Okay, all right. Okay, 118 minus 70 gives me what? Okay, so then I'm gonna add all this mess up. Okay, tell me what you get. Huh? 228. And then what's the next one? 222. And then 450. Ta-da! So what is the probability that a student that selected super strength, so out of the 26, how many are males? Is it 96?
Yeah.
Okay,
Yeah.
96% of the students that selected fly. How many, I'm sorry, what percentage of the students selected to fly as their favorite superpower? So that's gonna be 100 out of the 450. That's, I don't know about you, but I'm feeling 22. What is the probability that a student, what is the probability that a student is female and she selected telepath as their favorite superpower? So out of the females, how many selected telepath? 70 out of the 228. So what is that? 50. That's 31%. Yay, Macy.